Welcome to this edition of Momentum. I'm your host, James Warnock, and joining me today is the William and Sherry Berry Endowed Chair in Engineering and Head of the Department of Agricultural and Biological Engineering, Dr. Jonathan Pote. Jonathan, it's great to have you here with us today.
Thank you, James.
And there's some big news coming out of the department at the moment. They have just announced that starting in the fall of this year, we'll have a undergraduate program in biomedical engineering.
Right.
Maybe you could tell us a little bit about that new program, what we can expect, but also how that's different from the current program that we have in biological engineering.
Sure. The biological engineering program was the first in the U.S., and at the time there was no differentiation between biological and biomedical until I think it was Duke, maybe about 5 years later, had the first accredited biomedical. So for us, for many years, biomedical was a concentration of biological, and they were certainly able to do everything they wanted to do. At the same time, biomedical has emerged so strongly as its own area now that it really was time that we have our own biomedical, fully accredited biomedical engineering degree, as well as the accredited biological engineering degree.
And what sort of things will students or graduates from the biomedical engineering be doing career-wise versus the broader biological engineering students?
The biological has always been very broad span. A subset, the ones that deal with humans, are the biomedical. All the rest can be doing anything, animals, plants, fish, etc. The biomedical is going to be fully concentrated in biomedical. Of those, almost certainly a relatively large number will be planning to go to medical school. Then there's a large segment that will go into biomedical engineering, which the Office of Labor and Statistics keeps listing as one of the fastest growing areas of engineering right now. And that set there are plenty of jobs available at the bachelor's level, but they don't tend to be in developing new products, and most of our people are very interested in that, so a relatively large number of them will actually go on to graduate school in biomedical engineering.
Okay, and the faculty that you have in the department at the moment, again, a very even split between biomedical engineering and biological engineering.
Right.
What's some of the research that's been going on in the department recently?
A lot of fun stuff. I have one of mine, Lakeisha Williams. Her specialty is head trauma, neural damage. Specifically, her work looks at the brain itself and what happens during impacts of different types. Even more recently, what happens when you get an explosion, so that there's not mechanical damage, but there's air pressure change so rapidly. And I could go on further on that, but looking over at the other side, I've got Anna Lindhaas, who has landed a whole series of grants which are looking very strongly at oysters and where we can get them restored in the Gulf, and what setting gives us the best chance of getting restoration to work out well.
And that sounds like it would be something that would have a lot of benefit for the economy in Mississippi.
Very much, very much. She, in her preliminary work, it was very interesting to see in that she looked at how heavily was it impacted by Katrina, and it was heavily impacted, but it rebounded very rapidly. When the oil spill happened, it dropped again, and it did not rebound. And so we're still sitting at less than 20% of our usual harvest. It is a big deal.
So the biological engineering program, been around since 1967.
Right.
That means we're at the 50th anniversary of the program. Any big plans for this year to celebrate?
Absolutely, absolutely. We plan on having a big celebration in the fall. It'll be during a home game, and we plan to invite back all of our alums, all our friends, and it should be a lot of fun. We have a subgroup that ought to be good. We at one point had 5 of our graduates in Johns Hopkins Medical School all at the same time. Right now, they're all planning to be there.
Well, that should be quite an impressive class to have back on campus.
It will, yeah. 2 of them only have to come from Jackson, but the rest have to travel quite a bit further.
Yeah. Well, Jonathan, it's been great speaking with you today. We're going to take a short break. Our guest when we get back is going to be Dr. Dennis Truax, who is the department head for the Department of Civil and Environmental Engineering.
If you want to have a big impact in the world, you have to start small. At Mississippi State University, we're starting in the Gulf of Mexico, where a small but crucial barrier island is quickly fading from view. Millions of state dollars are spent dredging sand to replace the vanishing shores of Deer Island, but we think we can do better. We're applying cutting-edge sediment tracers to map the flow of currents and predict the course of sand that's carried out to sea, a process that will help us better understand the drastic transformation taking place. While this is a more cost-effective way to prevent the loss of an island, it's about so much more than saving dollars. It's about taking the first step in a long process to preserve our environment and secure a better, brighter tomorrow. We might be starting small, but rest assured, at Mississippi State University, we're dreaming big.
Welcome back. My second guest today is Dr. Dennis Truax. He is the James T. White Endowed Chair and the head of our Department of Civil and Environmental Engineering. Dennis, it's great to see you today.
Pleasure to be with you, James. Thank you for the invitation.
You're very welcome. Now, I've seen you talk several times to prospective high school students about coming to Mississippi State and studying civil and environmental engineering. And one of the things that I've always noticed is the passion that you have when you're talking about your field of study. Tell me, what is it that really got you passionate about civil engineering? You know, what was it that really captured your imagination that made you feel like this was something that you really wanted to devote your life to?
A good observation, and it's been pointed out to me on several occasions that the passion that seems to come. And the truth is that if you look at what civil engineers do, what we do in general, and I'm, with my engineering background focused in environmental and water resources, that's just one of the many areas that we do this. Our profession is focused on making things better for people. It's making a difference. So what we end up doing is a lot of times doing the things people take for granted. We sometimes frame it in the various organizations as really designing, planning, building a quality of life that the people in our communities want. That difference comes by providing clean water, sustainable infrastructure, roads, highways, bridges, rail, air systems, clean water, cleaning wastewater. And so that passion comes from not necessarily being able to do it, but seeing what the result is. As you know, that I've been involved in Africa with the college's Engineers Without Borders chapter. And as I was recounting earlier, it's really rewarding to see how simply putting in something as simple as a hand pump and a well and a sustainable water supply for a year-round clean water source, how that can change a community. We take it for granted. We've grown up with that. We drank water out of the garden hose when we played as kids, and water was always abundant and clean and safe. But over there, and here too, providing that water changes lives. People become more empowered, their health is better, their economic growth is better, and it really is a life-changing result. And we have that every day as a civil or environmental engineer.
I'm glad you brought up the Engineers Without Borders. I know that the students have won a number of national awards, some very prestigious awards, and you take a group of students to Africa every summer.
We do.
Part of that. What are some of the things that the students get to do while they're over there?
Well, again, always looking for opportunities. The original mission of the 5-year project was to put in sustainable drinking water, potable water, not for agriculture so much as just to make sure people had good water to drink, clean water to cook with, to some degree bathing. While we were there, we found that there were a number of opportunities for the students to get involved in. So in addition to helping drill the borehole, install the well casing, place the hand pump, do the water quality testing, and periodically checking and ensuring that the wells being, the pumps are being maintained, that the water supply remains safe. One activity we got involved with was a youth soccer program. And we took balls over and played with the students. Well, the students played with the students, and we engaged them in recreational activities. We've taken materials over and engaged in a hygiene program that our NGO works with, and teaching individuals about the importance of proper hygiene. One of the traditions over there is that when we put in a well, they actually will kill the fatted goat and have a celebration. And in a few occasions, we'd get there, work way into the night, and they would just give us the goat and tell us to go home and kill it ourselves. And instead of killing the goat, we started an animal husbandry program, which is made up mostly of goats and chickens, again, all gifts. And we've farmed those out and loaned those out to individuals in the communities that we work in to develop those programs.
So it sounds like you're doing a lot more than just engineering when you go to Africa.
Well, we do. Though the Engineers Without Borders chapter is focused on the water supply piece, it is a multidisciplinary team. We have chemical engineers, industrial engineers, civil engineers involved in this activity. And much like civil and environmental engineering, we're engaged in people's lives making a difference. And it's not just one difference, it's a more holistic impact that we have.
Okay, that sounds great. Now,
and that's why the passion.
Bringing it full circle there for
yes.
us. So just quickly, for those students that don't want to go to Africa or may not be able to go to Africa, what are some of the things that they might be able to do here at Mississippi State in civil engineering?
That's
very briefly.
That's a difficult part. The easiest part is to come up with a couple quick examples. Within the Department of Civil and Environmental Engineering, we have a number of faculty that are engaged with students as part of an active learning program. We'll take undergraduate students into the lab, particularly during their junior and senior year, once they've mastered the fundamental engineering, and they may be working on the next generation of concrete that'll be used. And in fact, we're engaged in the design of a concrete that'll be used in the new baseball stadium expansion. Or they may be involved in designing the next generation of asphalt for roadways here in the state or in the South. Or they may be working on a biological fuel cell and trying to close the loop and advance the next generation of biodiesel, biofuels by treating wastewater, reclaiming energy, and in the same sense generating a renewable energy source.
That sounds like there's a lot of great things going on.
There are.
And unfortunately, that's all we have time for today. Thank you for joining us. We hope you will join us again next time. Remember, you can always follow us on social media to find out all the latest things happening in the Bagley College of Engineering.